Good morning and once again welcome to my YouTube channel, Pearson with Excel International Math by Mr. Kamoto. And in this video we're going to look at example 6. This is example 6 and 6b for that matter. We're going to look at integration by substitution, pure mathematics 4 page 74, and I'm going to explain example 6 part B. And we're told to find the integral of x root 2x plus 5. This is example 6 part B, and we have just finished with example 6 part A, so it's a continuation of the same. Of course, substitute this, or rather integrate this using the substitution u squared is equals to x plus 5. And as you can see, this is the substitution that we are supposed to use, and u squared being 2x plus 5 to start with. If you look for the square root on both sides, you will agree with me that u is the root of 2x plus 5. It goes without saying. And having said that, if u squared is 2x plus 5, if we attempt now to get the differential of u with respect to x, because we must substitute dx, we are saying that 2u is equals to 2u, and of course before we get even to 2u, because we are differentiating u with respect to x, it is important to apply what we call implicit differentiation. And implicit differentiation will take us somewhere. We know the integral of this one is 2u, and of course because we are differentiating with respect to x and there is no x here, we talk about du dx. Remember, something to do with implicit differentiation, which is equals to 2. And of course, our main objective here is to make dx the subject of the formula, and it goes without saying 2 dx is equals to 2u du. Dividing both sides by 2 gives us that dx is equals to u du. That is a very important piece of information. And the moment we have this as u squared as 2x plus 5, we are through with this part, but we are not through with what x could be. So from this, making x the subject of the formula, from u squared is equals to 2x plus 5, making x the subject of the formula, it goes without saying that x is equals to u squared minus 5, everything over 2. And having said that, now we need to substitute everything here and integrate x, which is u squared minus 5 over 2, multiplied by u, this is of course u, multiplied by u, root 2x plus 5 is u, multiplied by u, of course, with dx being u du times u du. Opening now the bracket, and of course we have u times u is u squared. U squared times u squared is the integral of u raised to power 4, u raised to power 4 minus u raised to 4 minus u raised, or rather 5u squared, everything over 2, and we have du there because this u has been used to multiply out this. Now separating the terms, we can just write them because both of them are sharing the denominator, so we can have the integral u raised to power 4 over 2 minus 5 u raised to power 2 over 2, all with respect to u. And at that particular point, now we can integrate everything and have u raised to power 5 of course, we have a half u raised to power 5 over 5 minus 5 u raised to power, of course, there's a half here, there's a half there because of this over 2 u raised to power 3 over 3 plus c. And the moment we clean up this one a little bit, we are going to have u raised to power 5 over 10. We are going to have u raised to power 5 over 10. And this is going to be 5 over 6. It's going to be 5 over 6 minus 5 u raised to power 3 over 6 plus c. At that particular point, now we can substitute for u. But of course, u was the root of this, or u squared was the root of, or u squared was 2x plus 5. Now, but u squared is equals to 2x plus 5, and by extension, u becomes the root of 2x plus 5, which is also 2x plus 5 raised to power a half. So substituting this, we are going to have u, which is raised to power 5, which is this is u, 2x plus 5 raised to power a half, now which is again raised to power 5 because this is u, 2x plus 5 raised to power half, and itself is raised to power 5. We are going to see what happens there. Everything over 10 minus 5, 2x plus 5 raised to power half raised to power 3, because this is the u itself, but u is raised to power 3. Everything is over 6. Simplifying this using the law of indices, we multiply out the indices. Half times 5 is 5 over 2, and the final submission, the integral becomes 2x plus 5 raised to power 5 over 2 over 10 minus 5, 2x plus 5 raised to power a half times 3, which is 3 over 2, everything over 6. And that is exactly, of course, plus a constant c, and that is exactly what we have in this particular question. So if you compare this answer with the one we got in the previous example, that is 6a, part 6a, they are both leading us to this answer, meaning that either we substitute as illustrated in part B or as illustrated in part A, we would get to the same answer. So that is it. And of course, once again, visit my YouTube channel. You have seen what we have been able to substitute. We have everything, and the final subscribe, let people subscribe, and let us walk together along these mathematics.